We're working in JavaScript and Node to create an API-driven backend using the Express framework. Now, the architecture we're creating has an HTTP server provided by Express, has a bunch of middleware that we're writing. We're using a database connector called Connects, which talks to a Postgres database. Requests come in, they get converted into JavaScript objects. We work on them in our middleware, and then we talk to a database, again, using JavaScript idiomatic code through our connector. That thing connects to the database using SQL, does the query. Database comes back with the response, gets converted back into JavaScript objects, and then our middleware processes it, transforms it back into a valid HTTP response, sends it back out over the intertubes back to our client. Let's take a closer look at our middleware architecture. We have some middleware that processes every request. This is stuff like Morgan or Helmet or the cross-origin resource scripting. So all of the requests go through that middleware. Then there's middleware that we write ourselves that is unique to a particular route, a particular endpoint. And we have code that responds, that matches this URL and this HTTP verb and responds, creates a response, again, talking to the database, whatever it needs to do, and then that response gets shipped back out to the server. We're going to use a testing technique called integration testing. We're going to simulate that HTTP transaction using a testing framework, and we're going to verify using those tests that our middleware is written correctly, that it talks to the database correctly, that it processes these requests and sends back the response just as it should. We're going to replace the HTTP server with a testing framework using something called Supertest, something called Mocha, something called Chai, a bunch of libraries that have been used for a while and are very reliable, very easy to use. Things get a little complicated, so we're going to break it down into the pieces so you can see how all the pieces play together. First, let's take a closer look at some of the theories behind tests. Okay? So, let's look inside this testing framework. First of all, every test is broken down into a test case. A test case focuses on one particular thing. We're asking the question, if I do this thing, does it work? Does it produce the correct data? Every test case has 4 phases. The first phase is the setup phase. That's where we create whatever data we're going to feed into our backend, and we're going to create whatever data we're going to expect as a response. So we'll create the request object. We'll also create an expected response object. We'll also create any data that is required inside the database to make sure that the middleware has something to talk to back at the back end. Okay, so now we got all our data ready. Everything's set up. Each test case stands on its own, so it has to do all of the setup it needs. At this point, we invoke the test point. The next phase is a stimulus phase. It simulates a transaction by stimulating the middleware. The middleware does whatever it does, and then the response comes back. Our third phase is to check that response to make sure that it matches what we're expecting. If it doesn't match our expectations, then we're going to flag it as an error and go on to the next test case. We want to make sure things don't stop when we run into errors because, there are a lot of tests. We want to get through as many of them as we can. We're just going to collect up a report. Finally, the fourth phase of every test is the teardown phase. The rules are that every test has to stand on its own. So if we create data in order to run our tests, we have to remove that data. If we put records in a database table, we have to remove those records. We want to be able to run these tests in any order. So each test is responsible for getting the data set up and then removing the data later. Set up and tear down. It's like when you go backpacking in an environmentally sensitive area, or frankly anywhere. You bring in whatever you're going to need and you pack it all out. You want to leave it untouched, as if you had never been there, so that someone else can come along and use this thing the same way with the same experience. All right, 4 phases in each test case. Now, it takes a lot of test cases to run through all of the various functions of an endpoint, so we use a test framework to manage all of these test cases. Our test framework is called Mocha, and it provides a test runner, among other things. We go through test by test and trigger the middleware, check the response, trigger the middleware, check the response. You can control whether you're going to run the whole test suite, just one test, a subset, whatever you like. As time goes on, this test framework will be running these tests over and over. As you build them, you'll be running them over and over to make sure nothing breaks as you continue development. Taking a little more detailed look into our middleware for a particular route, we are going to, for a given URL, want to handle all of the CRUD operations, the create, read, update, delete. We're going to have endpoints, and each one of those will use methods from what's called a service object. We're going to collect up all of the logic and all of the algorithms and all of the processing that's required to manage those requests and to interact with the database. We're going to put them in a JavaScript object with a number of methods. Oddly enough, these methods correspond directly to the get route has a get method, the post route has a create method, and so on down the line. They'll also have other methods if you need them. Like a lot of times a delete method, well in this class a delete method will delete things, but a lot of times a delete method is more sophisticated than that and may require other methods to support it. So you'll have whatever you need in your service object. We're going to test this architecture using integration testing. Let's focus on just one of these routes, just the get on a particular URL. We're going to break our code down into a router, the thing that is concerned about the request and the response, and a service method, the thing that is concerned about the resource that is being accessed through that router. The main concern of the router is that HTTP transaction. We're going to parse the request, we're going to validate any parameters, we're going to invoke the service method that's going to go get the resource or put the resource, whatever it's supposed to do. We're going to bring back the results there and format up an HTTP response. And along the way, if we have any problems, we're going to handle the errors or any kind of 400 or 500 statuses that need to be done. Now, that's all HTTP. In contrast, the service method is mostly concerned with managing the resource, making sure that we can get to the database, format up whatever comes out of the database correctly into the JavaScript object that the router needs, and just focus on that. So when the service method, when the router invokes the service method, it will use connects to create an SQL query. It'll submit that query using a method chain, as we've seen. We'll get the results back asynchronously using promise-like objects, and then we'll process those results and return them back to the router, where they will get formatted up as a response and sent back out across the net. So, as you go along and you create tests for this combination of router and service method, your tests will verify that each of these steps are operating correctly, that you're validating your parameters correctly, that you're invoking the service method correctly, that it's talking to the database the way it should, that it's handling the results the way it should, and that the response will be formatted up, and any errors that might occur in the unhappy path will be handled correctly as well. We're going to use something called test-driven development to create these endpoints, these combinations of routers and service methods. This is a cyclical process. It's a process that repeats and repeats until you're done. So when you first are starting on working on a particular endpoint, you'll say, does the endpoint do everything it's supposed to do? And when you're first starting out, it doesn't do anything. There's no code there at all. So when we ask that question, does the endpoint do everything it should? The answer is obviously no. So the first thing we do is we write an integration test. We write a test that says, if I give it this request, do I get this response back? And of course, no, it doesn't work because there's no code. But we write the test first for a number of good reasons. Number one, it helps us focus on just that particular functionality, just that particular transaction, just that particular aspect of this endpoint. It helps us focus on writing the code for that functionality and only that functionality. It makes for very small, lightweight, efficient code. When we've written that code, the test passes. And our focus in this phase is not to make the code elegant or efficient or any of those aspects of quality that come after functionality. We're only concerned with just making the test pass, just making the endpoint do what it's supposed to do. Once your tests pass, then you've got a leg up on this and you can refactor your code. You can change the code the way it's written without changing what it does. That's refactoring. Because your test now provides a safety net with you. If you don't like the way you wrote the code before, if you can think of a more efficient way of doing it, knock yourself out. As long as your test passes, as long as you know that your endpoint is doing what it's supposed to do, you can run with scissors. Don't worry about poking your eye out. This cycle is called red-green refactor. Start with a test. It will fail. It will be red. Write some code. Your test will now pass. It'll turn green. And then you can refactor and make your code better if you like. You can save that refactoring for later after you've got all your tests running, or you can do it on the fly. It doesn't matter. It does matter, but it depends on a bunch of factors that are important here. When you've got that code working, when you've got that one test passing, then commit your code, put in a decent comment. This is your safety point. If you ever have trouble later on, you can back up to this commit, and you can know that at this point, at least, your test was passing and everything was good. Then you go back around and you ask that question again. Does the endpoint do everything that it's supposed to do? Does it validate all its parameters? Does it process errors, all that sort of thing? Probably not. You've only written one test. You've only focused on one thing. So you go around this cycle a couple of times, not too many times. I mean, we're working with pretty simple endpoints, maybe 3, 4, 5 tests, and you'll have a pretty good idea that you have covered all of the functionality of this particular endpoint. It validates its parameters. It invokes the service method. The service method processes the request correctly and generates the response correctly. Things get stored in the database if they're supposed to. Things get deleted from the database if they're supposed to. All of the various aspects of this one endpoint are now thoroughly tested and thoroughly verified. And each time we've built that endpoint higher and higher, we've created a git commit so that we have a safety point. When we're done, when the endpoint does everything it's supposed to do, you're out of here. You go on to the next endpoint. Or if you finished all your endpoints, you can go take a break. Write some client code, do whatever you like. That's test-driven development. Test first, red, write code second, green, and then make it elegant and efficient later, refactor. So let's go through this specifically with our architecture. We're going to have a test file, a router file, and a service object file. When you create those files out of your boilerplate, you'll have some stub code in them. You'll probably have some boilerplate having to do with verifying that a generic empty endpoint works. You'll have the generic code, the boilerplate code in the router that makes sure that you're talking to Express and you've got that other middleware all set up. You've seen this in your boilerplate. Your service method object will have its connection to the database ready to go. You'll have to set up a new test role and a new test database. You won't use your development database for this. You certainly won't use your production database for this. So at this point, you've got your basic boilerplate ready to go to start factoring in your functionality, building your functionality. There's a couple different schools of thought around how you work this iterative process. One is you think up a test, you write the code, you come back around, you think to yourself, can I have some more tests? Are there more tests to be written? Um, that's fine. That's good. That's a good way of doing it. It's especially when you're writing something and you're creating things. Now, when you're creating something from requirements, where someone, say one of our checkpoints, tell you, all right, you've got to have this endpoint. It's got to take these parameters, these query parameters. It's going to have these route parameters. These parameters have these various data types. These are required. Those aren't. When I give you a request, it has to do this thing, and then it has to do this other thing. And if it doesn't do those, then I want you to give me this kind of error or perhaps that kind of error. If you've got a full set of requirements, you can lay out the tests that you have to write. You don't have to actually write the tests, but you can lay out the tests just by using those it blocks. If you know all of your requirements out front, you can put placeholder tests in. If you don't know all your requirements up front, that's cool too. You can just start with one test. So you write that first test and then you run it. It has to fail. Along the way, of course, you've written some code to fill the database with test data and to verify that the request matched or didn't match its requirements. But the point is, there's no code here yet. There's just these boilerplate files. So of course, the test is going to fail. So you go in and you write whatever code you need to make the first test pass. You add the endpoint in the router. You put in whatever validation code is required by this particular test, not all of it, just this particular test. And then in your service object, you create the method that the router uses to talk to the database. Again, you're going to create some test data, put it in the test database, and then run your test. This time around, with your test data, your test talks to the router talks to the service method talks to the database, and bing, bang, boom, all the way back. And eventually, after you've gotten all the bugs out, your test passes. Cool. You are on your way to glory. You've got a little bit of router code, a little bit of service method code, and you're on to the next test. You write the next test, and you watch it fail. It's got a little different test database to support whatever it needs, or maybe it doesn't have anything in the database if you're checking to see what happens if there's no data. But you've got a second failing test, and that's the important thing. Then you go through and you write just enough code to make the second test pass. You may need to modify earlier code to make sure that it can handle these new situations. The cool thing is you've got that first test. You've got your earlier test sitting around to make sure that no matter what you do to modify the code to make it do more, it will never break what you were doing before. That kind of situation where an error sneaks in and your code that was good becomes bad again, it kind of regresses. That's an application of these tests called regression testing. That makes sure that you never let bugs sneak in to old code. So now you've got some new code, some refactored code. You can run this test again, and it will use your test data to exercise the router, exercise the service method, and when everything is together, that second test passes. You can see where this is going. You go through your cycle over and over. You write a test, you write some code, you make sure it passes, you write some test, you write some code, you make sure it passes. And then When you've got a complete set of tests, meaning that all of your requirements have been met, then you know your endpoint is complete. You have a complete set of tests that completely describe what the endpoint is supposed to do. They all pass because you've got a set of code that completely implements that endpoint, and you can go on to the next thing or take a well-deserved break.